Okay, now 153 is an Armstrong number. Why? You try it out and see. That is, find 1 cube plus 3 cube plus 5 cube and see what we're getting. 1 cube plus 3 cube plus 5 cube. So 1 cube is 1.
153.
3 cube, 3 threes are 9, 9 threes are 27, and 5 cube is 125. So you add all this, you're getting 153. See, so it is equal to the original number 153. Okay, such a number is an Armstrong number. Now, let me give you another number. Check if that is an Armstrong number. 132. Is 132 an Armstrong number? Check and tell me what you're getting for 132 when you do the same thing.
36.
Okay, anyone else? Huh? How much you getting? Let's see. 1 cube plus 3 cube plus 2 cube. That is 1 plus 27 plus 8. 28 plus 8 is 36. Correct? Okay. So we're getting 36 here, which means this number is not an Armstrong number because 132 is not equal to 36. Anna, you understood? Okay. So how do we do this program now? So we don't need this if, right? We're not checking anything. We're not doing any even or nothing. Okay, you just have your simple 3 statements. First statement is to extract the last digit. After extracting the last digit, we have to find its cube. Okay, extract the last digit, which is 2. Find the cube of 2 and add it to a s. Again, we need s here to add all the digits. Right. So here we don't do s is equal to s plus d, but we have to do s is equal to s plus d cube. Right, the extracted variable, extracted number d, we have to cube it and add it to c, to s. Let's say that again. First, for the number, look at number 132. What is the value of d first time? D, 2, the last digit. Right, we're extracting the last digit, d. And then what do we do with the 2? We have to cube it and add it to s. S is where we're going to store the sum of all the digits, 36. So s is equal to s plus d's cube. Okay, how do we find d's cube? Math dot power d comma 3. This is how we find d cube. Math dot power d comma 3 means d cube. Clear? Okay, so that cube of d gets added to s. So what's the value of s right now? First time, after the first iteration. 2 cube, 8. Only 8, right? 8 gets added to s. Then we are eliminating the last digit, 2. Now what is the value of n? 13. So from 13 we're extracting the last digit, which is 3. Then we find the cube of 3, which is 27, and add that to s. So to the 27 we're adding, to the 8, s value is 8. To that we're adding 27. Then we're throwing out the last digit. Should we do the dry run for this? Okay, if you do the dry run, you'll understand that better. Nathan, it's okay if your cat is walking around. It's not disturbing you. Just leave your camera. Listen here. Focus here. Okay. Or is troubling you? Okay, look, your n number is 132 first time, right? Now here d is equal to n modulus 10. So what's the value of d? 2, the last digit. Then what are we doing with that 2? We're finding its cube and adding it to s. What is s in the beginning? 0. So we're adding 2 cube to s, and so what's the value of it? 8. Okay, so now s value is 8. Next statement, we're doing n divided by 10. That means 132 divided by 10. So what will that become? 13. Here, first iteration is over. Okay, now starting again, n's value is 13 here, right? So now d is equal to what? From 13, we're extracting the last digit, which is 3. I'll write that full statement if you want, even here. Here d was 132 modulus 10, which is 2. Here it is 13 modulus 10, that is 3. Next step, s. S is what? S plus this d cube. That means, what is s? 8. 8 plus 3 cube. So 3 cube is 27. 27 plus 8 is 35. So s value becomes 35. And then last step, n is equal to what? N divided by 10. That means 13 divided by 10, which is 1. Correct? Then we repeat the same thing again. So d is equal to n modulus 10. That means 1 modulus 10. 1 modulus 10 means the last digit of 1, which is 1 itself. Then s is equal to s plus 1 cube. That's 35 plus 1 cube. And then last step, n is equal to 1 divided by 10, which is 0. Oh, here, sorry. 35 plus 1 cube is 36. And n becomes 0, then the loop exits. Right, the loop exits when n becomes 0. Okay, so what's the final value for s? 36. Right, that's what we got here. The sum of the cubes. What's the next step? What do we print? Do we print 36?
We check if sum is equal to n1. Store the value of n in n1
Correct.
because then we become 0.
Yeah. See, the question is what? To check if the number is Armstrong. The question is not print that 36. You have to check if it is Armstrong. And Armstrong means if this sum is equal to the original number. So is 36 equal to 132? No. So it's not an Armstrong number. Okay. So we need to check now. What do we have to check if it's equal? N and S. Okay. We need to check if n equal to s. If it is equal, then we'll print it as Armstrong. Okay, but yeah, there's a problem here, as Ryan just said. N was 132, but what happened to n finally at the end? It became 0. So your original 132 is lost forever. So what do we compare this 36 with now? There's no n to compare. Huh? Yeah, so we store that n in a what? What is that word? We store it in a separate variable. Okay, n is equal n1. We'll use another variable called n1. In that we will store n. It's like a backup. Yeah, that's the word I was looking for. So n became 0 here, but that number that we took from the user 132, we have stored it as a backup in n1. Okay, so now even though n became 0, N1 still has that 132 in it. So here we will check if N1 is equal to S. That is, if this 132, which is stored in N1, we're checking if it is equal to 36. If it is equal, then what do we print? Yeah, it is an Armstrong number. Else,
we don't print the number.
we don't need to print the number. The question doesn't say print the number. It just tells take a number and check if it is Armstrong. If you want, we can make it fancy. We can say 153 is an Armstrong number, like that. Okay. So if you want to do that, then what we'll write here before this, we will write N1 plus in quotes is an Armstrong number. You understood? That way you're printing the number also. So write that much. And else also we have else N1 is not an Armstrong number. Okay, I hope all of you are done writing this code. Yes. Now, as you may have noticed, in your school, you have so many weird names. What are some of the names? Chronic number. Okay, twisted prime. All right. There are so many Disarium number and perfect number, and there are so many different types of numbers they'll ask you to check, and they will always explain in the question. They will tell you what it means. You don't have to memorize. Okay, like here in this question, how it's written, check if it's an Armstrong number, and they've given an example. So they will always give you an example with proper explanation of what that number is. Okay, so you have to understand the question and make your code in the exam, because even if we do 10 programs on numbers, some other program only will come in the exam. Okay, it's not the same program. So you cannot memorize Java programs. You have to understand how to write the code and write the code. Okay, so as we do more and more programs, you should understand how to make the code then and there. You can't memorize code. Okay, there are some things you'll have to memorize, like public, static, void, main, all those things. Okay, but the logic and the coding, you have to do it then and there. Okay, now listen to the next question. Now in this program, we checked if a number is Armstrong. How did we check if it's an Armstrong? Let's run the program. We had to. What is this? Oh, what's the error? Oh, N1. I did not declare N1. Every variable that you use should be declared, right? Okay, S plus math.power. This also gave an error. Okay, why is that? Is math.power will return the answer as a double data type, and here S is a integer data type. So when we try to add integer with double, what can happen? Error. Okay, because they're not matching. So either both should be double data type or both should be integer data type. Okay. So what we'll do is we'll convert this math.power into an integer. How do we do that?
Int.
Just write int in front of it. Okay, that way this three whatever we are cubing, it'll get converted to an integer, and then we're adding that integer to S, which is also an integer. Okay. All right, enter a number. So we'll try 153 first. 153 is an Armstrong number. Got it? It's a maker. Country. Remember these answers. Okay, let's do the same thing again and try the other number that we entered, which is 132. So what will be the output? 132 is not an Armstrong number. Okay. So this program is good. If you enter a number, it tells you whether it is Armstrong, whether it is not Armstrong. But what if I want to know all the Armstrong numbers? How do I do that now? Should I sit and type 152, 153, 154, 155? That's the only way I can do with this program, right? So can I modify this program in such a way that it finds all the Armstrong numbers from say 1 to 1000? Can we do that? Can this do you think your computer can do that? Find all Armstrong numbers from 1 to 1000 with just one click instead of sitting and typing 1, 2, 3, 4, 5. You think it can do it? It can do it. So what changes should we make to our program so that it prints all Armstrong numbers from 1 to 1000? Anyone?
N is equal to 1 and N is less than equal to 1000.
So we need a for loop, right? Question is, write a program to print all Armstrong numbers from 1 to 1000. Write on the question. In our previous program, who was giving that number? The user was giving the number, right? We're telling the user enter a number, and the user is entering that number 153, and then we're checking it. But now what we're going to do is we're going to let a for loop feed in the numbers. So first the for loop will give the number 1, and then it will check if it's an Armstrong. Then the for loop will give the next number 2, 3, 4, like that all the way till 1000. So that way the user doesn't have to keep entering these numbers. Who's going to keep giving these numbers? The for loop. Okay, so yes, first of all we get rid of taking this from the user, right? Yeah, no scanner class because we're not taking anything from the user. Question is print all Armstrong numbers from 1 to 1000, right? So we don't need to take anything from the user. Okay, so remove the scanner class, remove this, right? What else? All this, no? We don't tell the user to enter the number. So this is also not there. Okay, so how do we feed in the numbers is we need a for loop. Not really. For loop will go from, will initial declare I. So I will go from where to where? Nathan and Ryan, put your cameras on. I will go from 1 to 1000. Okay, so first time the value of I is 1. So we need to check whether 1 is an Armstrong number. Then when I becomes 2, we have to check whether 2 is an Armstrong number. When I becomes 3, we're checking if 3 is an Armstrong number, right? So here, what we should put here? In our previous program, we were checking whether n was an Armstrong number. But now we have to check whether I is an Armstrong number, right? So here I'll put I. You understand? Your number that you're checking whether it's an Armstrong is going to be I. So just replace all the n's with i's. Or we'll do the other way. Let this be n. Here we'll put n. Is that better? And for loop n's value is 1 till n becomes 1000. So let it be n itself. Okay, that way less confusion. All right, so what this code, it checks whether that n is Armstrong or not. If it is Armstrong, what we'll do? We're printing it, no? Let's not print all these extra things here. Okay, we'll just print the number. Wait, n1 or n? So we'll do that also. We'll store that n in n1 and then we'll print here. If n1 is equal to s, we'll print it. Okay. So if the number is Armstrong, we print it. What if it's not Armstrong? What should we do? If the number is Armstrong, what are we doing? Printing it. If it's not Armstrong, what do? We won't print it. Because the question is what? To print all Armstrong numbers. It's not saying print the number if it is Armstrong or not Armstrong. Just answer what you can. If you don't know, just leave it. Don't ask. So do we need the else part over here? No, we don't have the else part, because if it's not Armstrong, we don't do anything. We just ignore that number. So we only have our if part. If it's Armstrong, we print it. That's all. Okay. Now this whole code should be inside the for loop. Okay. This much. This whole thing is inside the for loop from here to here. So your first n's value is 1, storing that in n1, checking if n is Armstrong. If it is Armstrong, then we are printing n1. And this whole process repeats again. 1,000 times this will execute. Here. Here. Ah.
How many questions are in the queue? How many questions are in the quiz?
300.
Huh?
Maybe 100.
Okay, no, no.
We don't need S. We have S. We don't need I. Okay, let's run the program and see. How many numbers do you think are going to be Armstrong from 1 to 1,000? One? Is it taking so long? Or? I think it's still executing, or it's stuck or something. The cursor is not blinking.
Anna, can we call this as a delay?
No, it's just slow. I don't know. Either it's slow or the code is wrong and it has gone into an infinite loop or something. What happened? Okay, let's reduce the size of the code just to see if it runs. For loop is from 1 to 10. Okay, we know 153 is an Armstrong number. So let's give our for loop from 150 to 160. Okay. Probably it's not going to the next value of n or something. Okay. See what's happening, no? See over here, what is happening to n? N is becoming 0. N is not supposed to become 0, no? See here, n is what? First time n is 150. Next time n should become 151. But inside this loop, what is happening to n? It's becoming 0. You need it to stay at 150. So what modification should we do here so that the value of n doesn't become 0? Okay, see, we have taken that n 150 and we have stored it in n1, right? Let's do all our calculations with n1. Let n1 become 0, not n. Let n remain at 150 because n is a part of the for loop, right? After 150, it has to go to 151. So don't do your calculations with n. Do all these calculations with what? n1. Okay, so do everything with n1 over here. Because what's going to happen to n1 at the end of this? It's becoming 0. And then your next value of for loop will be what then? After 0, it go to next. After 0 is 1. Plus plus. If you add 1 to 0, it becomes 1. Yeah, so don't change the value of n. Change the value of n1. So here we will check if our n is still remaining at 150. Okay. Let's run the program, then I'll explain it once again. Code execution successful, but it did not print anything.
Now, do we have to print N1?
No, n only, no. Because at n1 becomes 0. We need to print n. N we are storing in n1. We're checking if n1 is Armstrong. Oh, sorry. No, correct only. Okay, this S, no, we have to make it 0 every time. After every for loop is running, we have to reset the value of S. Because what's happening otherwise? First, the value of S will be the sum of 150. Then you're adding 151 sum also, 151 sum also to the old S. So S is just accumulating all the sums of 150, 150, then 151. So you need to reset it back to 0. Here we are putting it as 0, but it's not here where we have to put it as 0. After every time the for loop is restarting, we need to set this S value back to 0. You're resetting S back to 0. First S will have what? The sum of 150. Next time S should have what? The sum of 151. And then it has to have the sum of 152. So every time the for loop is executed, S should get reset back to 0. That was not happening here. Okay, so now we're resetting it back to 0. Now we got our output. So from 150 to 160, it printed only one number, which is 153. That is the only Armstrong number. Okay, let's go back to our code and now check all the way from 1 to 1000. Here we have a list of all the Armstrong numbers from 1 to 1000. 1, 153, 370, 371, and 407. Clear, everyone? So just telling you what all changes we have to make. The initialization of S should be done inside the for loop, because every time the for loop runs, you have to reset your value of S back to 0. Is that clear, everyone? Then we should not do our calculations with N. If we do all these calculations with N, what will happen to N? It becomes 0. Your for loop gets spoiled then, because your for loop should have N value as 1, 2, 3, 4, 5, 6. It should not go back to 0, right? So do all your calculations with N1, not with N. Those are the two mistakes that we had done. We've corrected them. We can check till 10,000 also. You want to check all Armstrong numbers from 1 to 10,000? Let's see. Okay, nothing else. 407 is the last Armstrong number. Okay, write the code.